These two are going to show excessive multicollinearity. Remember what is multicollinearity? When the same variables are the two variables are telling you essentially the same thing. If I told you that my team made 100 extra points, that tells you something about how many touchdowns they scored, right? Unless you're Alabama, they have some kicking problems this year, but even with Alabama's kicking problems, if I tell you that they made 7 extra points in a football game, you know they probably scored about 7 touchdowns, right? Well, within 1 or 2. You got to watch out for that, and that is a real problem when people start doing these. When you start thinking of X variables, you're going to think of ones that are real similar to each other. Because when Shelby, why did you bring up extra points? Because we had just talked about touchdowns?
Yeah.
And you thought, oh, extra
well, no, because I am an Alabama fan and we're not very good with extra points. So
Well,
we can have 4 touchdowns and 2 extra points.
okay, here's just a
Or
little
1.
tip for you. If you're an Alabama fan, don't complain this year. Just say it.
Complaining, he did good on the game against Auburn.
All right.
So could you do touchdown and field goal?
I never first tried to.
You could perhaps. Julie brought up an issue here, a question here. Could we put number of touchdowns in my model and number of field goals maybe?
Yeah.
Maybe. You know, those aren't telling me the exact same thing about the teams. They may be related. I don't know. That's why we do a correlation matrix to see if they're too closely related. I can already tell you these are going to cause problems. These two, this is like the square footage and the number of bathrooms in the house. I mean, they are so closely related to each other, you're not going to be able to use both of those. That's why I suggest on this proposal sheet that you come up with some extra X's. You know, I said you've got to have 3 of these and 1 dummy. That's the minimum. You need to probably have about 5 or 6 of these when you start, because you may decide some of them you have to get rid of. Now, I do not take the approach, which if any of you are playing with the Hawks homework yet, I know the reason they ask this question, but in some of the Hawks homework, they have you do the model, and then they ask, can any of these variables be eliminated? That's the way they ask you, are any of these variables insignificant? I do not take the opinion that you need to eliminate variables just because they're insignificant. But you may have to eliminate variables for other reasons. Multicollinearity, or you can't get the data on some of them, things like that. So anyway, that's kind of how you need to be thinking about this. What kind of measurable question can I ask? Sports teams are very popular. We're going to pull up some state level things to look at here in a minute in case you don't have a good idea and you want to think about maybe doing states. Oh, one other thing that students sometimes have a little bit of an issue with. I'm requiring you to have 30 or more observations. That means if you're going to do sports teams, you have to collect data on at least 30 teams. If you're going to do states, you got to have at least 30 states. If you're going to do counties, you got to have at least 30 counties. If you're going to do individual people, you know, how much money do you spend at thrift stores? You got to ask at least 30 people. You got to have data on at least 30 entities. Now, I did mention, I think, in that long thing I sent out before Thanksgiving, I will waffle on that a little bit. I had a student once who was doing a soccer project, and in that particular league, there were only like 25 or something like that teams in the whole league, and I allowed him to go ahead and do that. But if you were going to do football, say, and you wanted to only do SEC teams, well, there's only 14. I would say no to that. You would have to do like another conference as well to get you close to 30. But you got to have at least 30 observations. Not 30 variables, but you have to collect data on 30 different things. Teams, states, companies, counties, people, whatever it is you're getting data on. So the Walmart girl that was trying to do the Walmart, she could have gotten data for her store, although Walmart might not have wanted her to, but she needed to get data on 29 other stores, so she could get 30 of those vision centers to do. She couldn't do that. That's why she had to throw away her idea and come up with something else last minute. Overall, the project is better if you come up with something you're interested in. Don't have to, though. It just makes it easier for you to talk about your project and explain your project. So hopefully, like I said, I wanted you guys to spend some time thinking about this at some point over Thanksgiving, so you might come up with an idea of something you're interested in. If you were not able to come up with something you're interested in, well, let me just kind of give you some things to look at that might sort of let you look around and find an idea. Like I said, I've got a lot of data sets out there that you can start to look at and say, well, I could do something similar. You can't use one of my data sets as posted as your project, but you might look at one of my data sets and say, well, that's interesting. I could ask a question about that. If you're still having trouble, though, and you can't come up with anything you're interested in, I often point students to the Census Bureau. And I included this link in the little thing I sent out before Thanksgiving. Go to the Census Bureau website, and what pops up, they've changed. I don't like the way they've changed it, but I don't like change in general. I used to be able to find this pretty easily, but now it's a little harder. Certification, okay, yeah, I don't want to sign up for the Census Bureau. I get enough junk mail. Well, shoot. Okay. Used to, this worked a lot easier. One of your classmates today was pointing out to me, if you dig around in this data, you can find an amazing amount of data broken down very low level. County, city, that kind of stuff. But if you just want an idea, you have no idea. I start with quick facts. I would just click on the quick facts, and it's going to bring up, now these topics that they have listed here are available for every state. Now it's going to be a little-ish time-consuming for you to do this over and over and over for each state. But once you figure out your variables, then it's pretty quick. You'll just have to do it for state after state, write down. So what I would do, if I didn't have any idea, I said, okay, I've given up on coming up with an inch. I'm just going to give up and do a state level question. And again, this is for the entire United States, but the data is going to be there for each state. So I would just kind of start scrolling down through here and say, well, what kind of question could I ask? What kind of number could I investigate that would be different from state to state? So, let me figure out my zooming here. There we go. So as I scroll down through here, well, here's one. Owner-occupied housing unit rate. That's pretty exciting, isn't it?
You said no
Well,
real estate.
Ma'am?
You said no real estate.
I said you couldn't do house prices. You might decide, do you think there are differences from state to state in home ownership rates?
Yes.
I suspect some states have higher home ownership rates than others do. So that could form a question. What kind of things might cause some states to have higher or lower home ownership rates than others? So I've identified a potential Y variable here. So that, I would, if I were just scrolling through this thinking I might write down Y, potentially, home ownership rate. Well, what kind of things might cause some states to have higher or lower home ownership rates than others?
Price, income.
Well, let's go with income first. Maybe an average income or a median income level for the state. Well, if you scroll on down through here, sure enough, here's median household income. So there's a potential X variable. Now, Beth brought up a question there, or a possible X variable there, price. But remember, this is state level data. We're not looking at individual houses. You might be able to Google, although the Census Bureau doesn't have it, you might have to go to some other website and Google median home price per state. So, that can be an X variable, but the Census Bureau isn't going to have it. But income, I think that certainly could be a good X variable. Do you think education levels might affect home ownership from state to
Yes.
state? Potentially, and if you notice, I think it was up here, there are some education variables. There is percentage who are high school graduate or higher, percentage bachelor degree or higher. Now think about it. Would you include both those as potential X variables? Do you see a potential problem with including both those?
Too related.
Starts with M, ends with a Y, got multicollinear in the middle. I don't know, but maybe those two are kind of telling me the same thing. They're both measuring how educated the state is. So you might not want both of them, but you might want one of them. The same thing is true. Same thing is true about race. You might want to include a race variable, but you would not include percent white, percent black, percent. You wouldn't include every racial category, but you might pick one and put that in. See if that affects home ownership rate. You might decide you wanted something else, like the unemployment rate in the state. But again, that's not going to be on this website. You're going to have to go somewhere else to find. So you may have to go to 2 or 3 websites to find the data you want. But as you scroll through quick facts, you might come up with an idea and just jot down some things you're interested in. And then once you figure out, okay, these are the 3 variables I want to get from the Census Bureau. The Census Bureau has some tools that will let you pull and extract data, but for this project, it's not worth the hassle of trying to learn how to use those tools. I would take a notebook and I would write up top, y equals, if I were going to do home ownership rate, I would create a column for home ownership rate. I would create a column for median income. I would create a column for, whatever the next variable I wanted to get. And then I would go state to state. This is for the United States as a whole. Say one of my states was going to be Alabama. Plug in Alabama, and the same numbers are there. So I would then scroll through and I would write down what the value is for Alabama, what the value is for Alabama. Do that for Alabama, then do your next state, do your next state. It's gonna be, it's a little time consuming for you to do this, but once you identify which variables you want, it doesn't take long, especially after you do a couple of states. You're gonna know where the variables are. They're gonna be the same place for every state. So once you figure out what your variables are, and you pick out which states you're gonna use, it's not gonna take you long to get this data. Now, like I said, you may have to go to another data site or another website if there's a variable you want that isn't here. But once you come up with your list of variables and the states you're going to collect data on, or the baseball teams, or the countries, or whatever it is you're doing, once you come up with your X's and your Y, it doesn't take that long to get the data. And then after you get the data, you got to put it in Minitab. Now, ideally, if you could find the data already collected out there on the interweb somewhere, you might just be able to download it directly, but you can't really here. Here, you're going to have to kind of do this by hand and enter the data. Some other questions, though, you might be able to just find that data in a downloadable form already out there. But that's up to you. It depends on what question you're asking. But this is kind of, and again, I tell students to kind of just default. If they can't come up with anything else, just open up Quick Facts, kind of scroll through it till you find some question or some variable that you might want to try to explain. I don't want to give you too many examples of ones students have done in the past because I don't want you to just copy them. But scroll through here and you can probably come up with something that might be worth asking about. Yes, Kim?
The Y, the homeowner rate, we would need 30 of those?
Because you need 30 states at least. Now you could do all 50 states, and they probably got DC in here. Most students don't do more than they have to, but you gotta have at least 30. not 30 different variables, but you have to collect the same variables on at least 30 states. And I'll tell you, let me give you just a little tip here. There are lots of websites you can go to find data. In fact, there's one called, well, I don't know if it's still around, we'll see. State Health Facts. See if it's still out there, yeah. This is from the Kaiser Family Foundation, State Health, if you just Google State Health Facts, it's one of the first ones that pops up. This is a very good data site to get state level data on, mostly health related. And like I said, sort of do what I did at the Census Bureau. Pick a state, because every state's gonna have the same data reported. So just pick a state and then pick a category. You know, health coverage and uninsured, if that's what you want to look at. And it will give you, well, again, you can play around and you can see that there's a lot of health, state level health data that you can find on that website. I think this is a very good website. It's going to take a little work for you to pull the data out, but I think this is a very good one. There was another one, and I can't remember the name of it, and it's probably good, because whenever I would pull it up, it was like, you know, Pop Rocks candy or something. There were pop-up ads exploding everywhere, and click here to win this. And they had this data that I don't know where that data came from. I feel like my brother was kind of making this stuff up and put, if your source for your data is Crazy Eddie's conspiracy themed data.org, you might want to reconsider that as your data source. Wikipedia, I think Wikipedia most of the time is an okay point to look for some things. Especially if you're doing like country level data. Wikipedia has a lot of good, and most of it comes from a reputable source. They're just kind of collecting it for you there. But think a little bit about where your data are coming from. Question where your data are coming from, I guess. All right, so anybody want to talk about their individual question? And we can talk about why it's a great idea or what needs to be tweaked to make it a better idea.
We just have to have a Y variable, or do we have to come up with a question that we're trying to answer?
Well, your Y variable should answer a question. Like in my example, why do some states have higher home ownership rates than others do? I mean, the question is just a way to make you start thinking about what your Y variable is. What are you really trying to measure, predict, explain?
I can give you mine. You know, spoken about comparing college professors.
Okay.
This college versus another one.
All right.
Now, the data that I found, I think there may have been about 27 possibly.
Okay, is this data, is it like college level?
Yes, university.
Okay, so you have like a number for Calhoun and a number for UAH.
Yes, it would not pull Calhoun. It pulled Alabama A&M.
All right, but you have school level
Universities.
data, right?
Yeah.
So Beth had emailed me, and do you mind if I use yours? Okay.
You're fine.
She had emailed me and said, you know, I'm interested in maybe potentially looking at how much us, you know, rolling in the money college professors make. And I didn't know what kind of data she was going to have here, and so my email back to her was pretty much a data level question. And from what I'm hearing Beth say, she's essentially got a number for Alabama A&M, a number for UAH, a number for each school. What were some of your X's going to be then?
You're talking about the universities, so there's,
Well, some of your explainers. What were some of your explainers going to be?
well, I mean, if you want to do a comparison like X, I kind of thought about, you know, we could do professors, we could do associate professors, and they also have data for assistant professors. Now, if you wanted to distinguish even more, they have the male and female
All right.
as well, which would be over the period.
Well,
that
hang
they
on
got
for a second
sick.
though. Your Y variable is going to be, in some sense, income.
Right.
And at least what you had sent me in the email, I thought you were talking about questions like years of experience.
Yeah, but this data didn't pull that.
Well, we're gonna talk about this. What
Okay.
department you're in?
Right.
Do physics professors get paid differently than English professors do?
Right.
Things like that. You brought up the assistant versus associate
Right.
versus full professor kind of question. But this data that Beth is pulling is essentially, it's either a mean or median. Probably it's a mean. It's an average income or average salary at Alabama A&M.
Yeah.
But if we're looking at the average salary at A&M, some of these don't really work for that. Years of experience, it probably doesn't give you, you probably can't find an average years of experience, or there's no such thing as the average department. So what kind of data you have is gonna kind of lead you to saying this will or will not work. If I were gonna do something like this, if I'm trying to explain the average income or average salary, that's the word I was actually looking for there. If I'm trying to explain the average salary at different schools, think about things that apply to the schools, not individuals. What kind of things might explain why people at the University of Alabama get paid differently than people at Athens State?
Tuition rates?
Tuition might be something. So the average tuition, number of students, the enrollment at a school.
Football games?
Maybe, did you play in a bowl game last year? Maybe that could be a dummy variable. Did your school play in a bowl game last year? Is your school public or private? I can think of lots of dummy variables you can include. Does your school do they offer PhDs? Do they offer graduate degrees? That might affect. Student faculty or ratio, that's a big thing in education data. So you could do something like this, but what kind of data you have is gonna influence what kind of things I can include as X's. I had a student a couple of years ago that was doing life expectancy. He was doing countries. You know, different countries have different life expectancy. And so he was doing country level data, and I kept, trying to get him to come up with some other variables. And I said, think about some things that might affect life expectancy. And he said, smoking. And I said, well, yeah, smoking could, but countries don't smoke. Albania doesn't have a smoking number. And it was specifically with dummy variables. I was trying to get him to come up with a dummy variable. He was like, do you smoke? I'm like, yeah, but countries don't smoke. You can't ask Albania, yes, no, do you smoke or not? So what kind of data you can include, what kind of variables you can include, depends on what your data look like. If you're doing country level data, you can't ask questions like, do you smoke or not? What could you ask? Maybe average cigarette consumption per person. I guarantee if you Google it somewhere, somebody has that number. An interesting question could be, how many years of experience do you have? That could affect this, but if your data are average per school, that's not gonna be an X variable you can include.
And I couldn't find that,
Yeah,
there's
it's probably not.
tenure and
When I got your email, my question that popped into my head was, so you're gonna go around and ask 40 college professors, how much money do you make, how many years of experience do you have, how many classes do you teach per semester? That's the kind of stuff you would have to do if you wanted to do individual people. But if you're doing college-wide, it would be these kinds of things that you might want to include. Something else just popped into my head when we were talking about that. Oh, I remember. Let me just mention this as well. And I hate that I've already killed the Census Bureau website. But especially if you're doing state level data, you gotta be careful with something. Crime data is real popular. Students end up doing a lot of crime from state to state, essentially. And so maybe, you know, a student was gonna do, their Y variable was gonna be homicides. How many murders are there per year? So that was gonna be their state level data. Well, if you included, say, Alabama, Maine, and California, say those are 3 of your states. Now, you would have to have at least 27 more, but I'm not gonna bother writing out 30. If those are 3 of your states, do you already have an idea which one of those states is gonna have the most murders? California. Does that mean California is a more dangerous place to live? There's a lot more people in California than there are in Alabama or Maine especially. So a lot of the variables that are on the Census Bureau website, they have some, actually I don't know if they have crime on that. They have a lot of variables kind of like this. A lot of their variables will be reported not as the number of homicides, but they'll have homicides per 100,000 people or something like that. So what they've done is they've adjusted the number of homicides for population. If you're gonna do state or country level data, you need to watch out for that. If you're just using raw numbers, that's really misleading to use the raw number of homicides in Alabama compared to California. You want some sort of rate. A lot of the variables on the Census Bureau are in percents. Like the home ownership rate, it didn't tell you how many people in Alabama owned the home. It gave you a rate, a percentage. You either want percentages or like a per 100,000 people type number. This is why I want students to give me that proposal sheet, because I can then identify problems like this and say, well, make sure you get this in a rate, or make sure you get it per 100,000 people, or something like that. Again, I know I'm bouncing around all over the place, but I'm just remembering some problems that have come up with past regressions. But again, this is why I want to see that proposal sheet from you, so I can tell you, yeah, you're on the right track, but think about doing this, or think about doing that. And I will help you with your data. You know, I've had students who were doing state level data, but maybe the thing they were measuring, why do some states have more grocery stores than others do? And I don't know, I just made that one up. Because they found a website that told them how many grocery stores each state has. Well, out of those 3, which state do you think is gonna have the most grocery stores? I'm gonna bet California has more grocery stores.
Yeah.
But the student website they found, it didn't have it adjusted. It just had number of grocery stores. I can help you with that. I can show you how to adjust this if it's not reported that way. But this is why I need you to give me something for me to work on. Julie, did you have something?
Yeah, so.
The salary determines the best golfer.
That's an
No,
excellent question.
They only get paid
Julie
good
asked a
when they
very
play
good
good.
question here.
They don't get paid a certain amount.
Let's say we were doing home ownership rate, and this was given to me in like 60.4%.
The salary don't matter.
72.3%.
I mean, it could be a factor, but I'm talking about like average golf play. Not,
59.1%, so on and so forth.
I mean, yeah, of course, the
When I
best
go put
players
this
don't have
in
the most money
Minitab,
because they won the most.
I
But
can
that ain't
put these
determined
numbers in
why
as
they're the best.
60.4, 72.3, 59.1, or
This
I
is
can
the
put
stuff
them in
that
as
determines if they're the best.
Your question's
0.604.
not measurable.
You know, we can express
You can't
this two
measure
different
your-
ways.
your
You're
question.
better off probably doing the
can.
whole number version.
It's a
So
yes or no
put
question.
60.4 in,
No, those are the X
72.3,
factor. X factor.
59.1. It's gonna make your coefficients
but-
easier to interpret in the end. So I recommend if you're doing percents, enter the whole number
House
version,
prices
not
are
the
measurable
decimal version of
because-
percentage data. It just makes it easier to
Prices,
interpret.
right? How do you measure golf? Like,
But
If
ideally,
they have
what
golf
we're gonna end up with
okay.
is you guys are gonna all give me a proposal sheet. And I don't even necessarily want your proposal sheets tonight, because I have a feeling what you were thinking about before and what you're maybe thinking now may have changed, or you may have modified it a little bit as we were discussing tonight. So ideally, I would get if you feel really good about your idea, and especially some of us who've already talked about it and I've said, yeah, that sounds good, go ahead and start collecting your data. And if you feel super good about your proposal, go ahead and give it to me tonight. But if, you know, after tonight you've said, okay, I want to tweak mine a little bit, I want to still work with this a little bit, I want a proposal sheet from you by Wednesday night. You can email it to me or you can bring it to me Wednesday night, but I want an idea from you by Wednesday night, and then I can give you some feedback on this. Like I said, if you already feel really good about your idea, go ahead and start chasing down data. Or if it's easy for you to get the data, go ahead and don't put a lot of effort into data collection until I look at your idea. Once you get the data, and I know y'all are gonna think I'm lying, but I'm not. Once you get the data and get it in Minitab, once you nail your question down, you get your data and you get it in Minitab, this project is easily done in an afternoon. It's not something that's gonna take you a week to do. Coming up with the question, finding the data may take you
How about
a
that?
week. But once you get that, the project itself is it's not that big of a deal. And the best thing you can do, kind of preparing you for it, look at some of these data sets I've got. Run regression, see what's significant, see what is not significant. And maybe, you know, here's an idea. You might want to team up with somebody else in class. All right, we'll see. I'll throw it out there and see what y'all do with this, if anything. Maybe team up with somebody in class, take some of those data sets, and you say, okay, I'm going to do mammals and line rating. You take employee satisfaction, and I don't remember what the other one. Take 2 each, and just play with them, run some regression models, and then take those regression models and see if you can explain to the other person what you learned about that data set. Because that's what you're going to be doing with this. You're going to, at the end of the day, be able to tell me something about home ownership rates from state to state. What things matter, what things don't matter, which things are significant, which things increase, which things decrease home ownership rates. Yes?
Are we going to do the 7-step test for that?
Really, we've kind of gotten to the point now where we've sort of gotten away from the 7 steps.
Right.
There is a 7-step question behind every p-value. But, all right, first off, when we look at regression output, what are we looking at? Almost always we're looking at p-values. What does a small p-value tell us about a variable? It's significant. That's really where, I mean, really there is a 7-step process behind that. But now we're pretty much looking at coefficients and p-values now. So let me throw something up here just real quickly that I just thought of. Let me see if I can find it. Oh, I remember where it was. Again, this is not an actual assigned thing, but I was looking around today for a data. Okay, this would help if I did that, wouldn't it? So I was looking today for another data set that I could throw out here. And again, I don't recommend that you start with this one. Maybe start with one that's a little easier. I think the line rating one is pretty straightforward. Even if I don't know anything about line really. Except for some reason they still use forks when screw tops seem so much easier. But you know, that's about all I know about line. But I think the line data one is pretty simple in terms of your X variables and your Y variable. It's kind of pretty obvious. I found this other data set, which Dr. Payne, it came from his dissertation data, and he used this data set for a long time with the online Stats 2 students, and so I stole this one and put it up here. He was looking at, and there are a lot of variables in this data set that you might not immediately be able to figure out what they were measuring. So that's why I gave you kind of a key of what the variables are. So if you were looking to do a project, you know, if I were, and you can't do this project, but Dr. Payne's looking for a dissertation topic. And so he came up with this idea. Essentially, I mean, his dissertation advisor didn't have him do it the same way that we're doing it. But essentially, he said, I want to figure out why some parents spend more time with their kids than others do. So he came up with this data, and he found this California data for individuals. There are 400 individuals in this data set. And he got data on how much time in minutes a parent spends with their children face to face, not, send the kid over to the corner to amuse himself with the TV, but how much time the parents spend with their kids face to face in a day. And then he came up with a bunch of variables that might affect why some parents spend more time or less time with their kids. And so I threw this data set up here, and I think it's one that y'all could play with. Some of the things up here are dummies, some are not. Some might be more interesting than others. One piece of advice I have for you in building a regression model: don't take the kitchen sink approach. Just because you've got a variable doesn't mean you need to put it in there. So I threw this data set out here because it's got a lot of variables you might not even want to use. But here's another one you could just play around with. Actually, yeah, I've been kind of going back and forth as I was talking about this. Let's say we wanted to build a model to explain how much time parents spend with their kids. So my y variable in that case would be that variable called FaceTime. How much time the parent spends with the kid each day. Now I've got a bunch of other variables up here that might affect that. Age, what do you think that's measuring?
Age of
Well,
the
that's not the
Age of
kid's
the
age, goodness.
parent.
That would be the parent's age.
Right.
And then we have female, but that's not measuring how much femaleness a person has. That's a dummy variable, right? Person number one, what do you think that female variable tells me about person number one?
Number.
That person is not a female, right? That's a dummy variable, it's a 0, 1. All the people with ones are female, zeros not. Number of kids, what do you think that's measuring?
How many kids?
How many kids a person has? Child age, I have this on the key, that was the age of the youngest child in the household. Job, that's a dummy variable, 0, 1. What do you think a 1 would indicate there?
You have more than one.
They have multiple jobs. Do you think that might affect how much time you spend with the kids?
Yes.
Sure.
Yes.
So there's a bunch of variables up here that you could throw into your model. I wanted to walk through one because I realized as I was looking at this today that we haven't necessarily done something, I haven't spent as much time on something as maybe I should. So FaceTime, our predictors, let's say, will be age, female, number of kids, child age, and let's throw the white variable in there. I'm going to change my results to basic. Alright, so I just want to get some data. So the first thing I see here, the overall model has a p-value of 0. What does that tell me?
There is something.
Something in the model is worth talking about. There is some significance somewhere in the model. Now, before we try to figure out which things are or are not, down here is my regression equation. And I always like to look at it just to get an idea of the relationship. Age has a positive coefficient on it. What does that suggest to me?
That's going up per.
The older you are, the more time you spend with them.
Older the parent is, the more time they spend with their children face to face. That's what a positive coefficient there tells me. Notice the female variable has a positive coefficient as well. What does that tell me?
Mothers spend more time.
Ma'am?
Mothers spend more time.
Everything else held constant if you're female. So mothers, they spend more time with their children face to face than not female fathers, basically. Are any of y'all surprised by that? Number of kids has a negative coefficient. What does that suggest?
The less number of kids you have, the more time you spend.
Wow, that was the opposite of the way I was going to interpret it, but that was that. The more kids you have, the less time you spend face to face with them.
Yeah.
Or the fewer kids you have, the more time you spend face to face. Child age. Child age has a negative coefficient on it.
Younger they are.
What does that suggest? You like going the other way on this
But when
interpretation,
you
don't
get
you,
older,
Lisa?
they're
Lisa's interpretation is perfectly valid. The younger they are, the more time you spend. I usually think about this in terms of this going up. So as the age of the youngest child increases, we spend less time face to face with them. I wanted to talk about that kind of thing because we must have been looking at positive coefficients. Negative coefficients don't mean insignificant or bad. Negative coefficients just mean opposite direction. So as your youngest child gets older, you tend to spend less time with the child. Now, before you run off, just saying, oh, I figured out how to predict FaceTime with kids, these are our estimates of the effects. Remember, we need to talk about significance as well. The white coefficient here, and by the way, with data and stat stuff, don't be afraid to talk about sex or race or things like that. Now, try not to be offensive in talking about sex or race or anything, but if you think sex, race, anything like that has a role to play in your data, in your model, put it in there and see. What does this suggest? All else constant, if the parent in the model is white, they're going to spend an extra 1.3 minutes with their kids per day. Now, somebody might get offended by that. If the data backs this up, don't apologize for the data. But notice, what does the p-value on the white variable tell me?
Not significant.